Hello everyone, my name is Santiago and welcome to Cloud World. On today's video we are going to be working once more with Azure Functions. In this case we are going to be moving into more advanced topics working with inputs and output bindings. So that means we are going to be integrating the Azure Function with pretty cool services from the Azure portal. We are going to be working with a storage account, CosmosDB and also SignalR. We are also going to take a quick dive into the cognitive service for computer vision in order to extract information for the image. So let's take a look what we are going to be taking on board in today's video so we can get a quick grasp of the work that we are going to be following up. So with that in mind, we are going to be working with a very simple web application writing in Blazor, nothing too overcomplicated on that end. So this application is going to allow the users to upload an image to the Azure storage account using an Azure function. This Azure function is going to be using an HTTP trigger that is going to be the input for our image. From here, we are going to have another Azure function, which is actually going to be a blob trigger. So that means this Azure function is going to react to the events that happens in the storage account. So once the user uploads the image to the Azure function and is sent to the storage account, this blob trigger is going to be executed. In here, we are going to be taking the data from this new image and we are going to be sending it to the Azure Computer Vision. We are going to take a quick look how to extract very simple information using this great service. From there, we are going to be saving that information that we get from the cognitive service into CosmosDB. Then again, we are going to have another Azure function, which is going to be a CosmosDB trigger. So that means this one is going to be triggered once the document gets created into the CosmosDB, into the particular container that we are going to define. From here, this CosmosDB trigger is going to kick up an output binding, which is going to send the information to SignalR. And as you can see at the beginning of the diagram, the user is going to be connected to this SignalR throughout another Azure function in order to negotiate the token. But don't worry, I know this sounds like a lot of work, but we are going to be taking each one of these functions slow, step by step, so you can understand what we are doing. So let's start with the HTTP trigger to upload the image. Now let's take a look into the HTTP trigger that is going to be exposed as an Azure function. All the code that we are going to be working today is attached as part of the video description, so take a look into the repo and feel free to clone it and play with it. So the first part that we are going to have in here is going to be an Azure function, and we are going to make a quick look in what we have in here. So this Azure function is going to be an HTTP trigger, which is going to be the input of our application. And we are going to be taking, of course, an HTTP request via POST request. What we are going to extract is going to be the file that is going to be sent to via the user throughout the UI. And we are going to store this image throughout our blob storage container. One of the good things that when you are working with Azure function is that you not only can use any native implementation from the Azure function like input and output, but you also can work with another services. In this example, we are going to be taking leverage to the usual blob service client in order to interact with the blob storage and save our file in there. So once we have our image and we have the proper container name, we are going to be sending the image to the blob storage. So let's take a look. So we retrieve the service client, the container client required to upload the file, and from there we make an upload to the blob storage. Now our image is going to be stored in there. Now let's take a look into one additional code. As part of this request, I also created some code so we can get the SAS URI from the image. So that means we are going to get a temporal URL so the user can access the image. The image is going to be visible throughout the web application. So in case you don't know what is a SAS URI, it's a temporal URL that gets signed with a particular key. In this case, we are using something that is known as user delegation key. And one of the important things in here is that we are not using any keys to authenticate to our services. If we take a look into the local setting.json, you will see that we have all the URLs for our services in here, but we are not using any keys. So when using the delegation key, we are actually using the Active Directory in order to generate the token. In this case, since we are going to be working locally, I will be using my account that is connected to the Azure portal. If you deploy this application, the user delegation key is going to use the managed identity, or maybe in some cases the service principal. Just remember to have a preference for the managed identity when working with new applications. This URL is going to go back to the UI and is going to allow the web application to display our image. So this is nothing too overcomplicated. Here is important to note that our function is going to be triggered via an HTTP, and this is another concept that is actually pretty important to understand. What is actually going to trigger our Azure function? In this case, it's going to be an HTTP trigger. So now that the image has been placed into the Azure Blob Storage, let's take a look into the Azure function that is going to be executed async after the blob has been put into the storage account. Now that we have our blob into the Azure Blob Storage, we can take a look into the blob trigger function. Here we will find a couple of things that are actually pretty new. So in this case, we are going to have a blob trigger, which is going to be executed where any document gets placed into the attachment container throughout any file. Also, we are going to be using the connection name storage account, which is located in our location settings. Remember that you can give whatever name you like to this connection string, just to make sure that you follow the convention. What does that mean? As an example, when working with any storage account in an Azure function, you can provide any name that you like at the beginning of the variable, but after that you will need to provide 2 underscores, and after that provide the blob service URI and the queue service URI. This is actually pretty important to use this notation, especially when making the authentication throughout any type of Active Directory. Then again, that will be like your local account to the Azure portal, or maybe a managed identity. So now that we have our connection in place, I would like you to take a look into something pretty important. We are going to be working with outputs. So that means anything that this Azure function is going to return is going to be processed by the output that we define in here. In here we have, in this case, a CosmosDB output. So we are going to be targeting a database name, which is going to be images.db, into a container name images, and we are going to be using the CosmosDB connection that is also placed into in the local settings.json. So let's take a look very quickly. So what we are going to do in here is we are taking advantage from the computer vision API, which we have defined into the program.cs. And since we don't have any implementations that are specific for this one into the libraries defined for the NuGet packages, I created a very quick definition. So what we are going to do is then again, using Active Directory authentication, we are going to be requesting a token in order to access the services that are part of the computer vision services. With that in action, we will be able to use the Azure Client Factory as many other services and retrieve the client that we need to. In this case, the name is Computer Vision. Now we are going to be using this API in order to connect to the cognitive service, in this case the Computer Vision, in order to extract images and analyze an image in a stream in this case. So one of the inputs that we can take for a blob trigger is the stream, which is going to represent the file that has been uploaded recently. Using this stream, we are going to request to the Computer Vision to extract from the image any tags, objects, and a description of the image that is actually being found by the AI when it makes a scan. After that, we extract very quickly the tags, the objects, and the description as just basic strings, and we process a new document. Let's take a look into this class. This class is going to provide 2 things, an ID and an image ID. So that will be the ID of the document, and image ID is going to be the partition of our key. We will take a look into a moment into the Azure portal so you can understand what I mean when talking about these 2 concepts in CosmosDB. From here we have all the other variables like the tags, objects, and description which we are going to be storing in our database. So take a look. We don't have to specify any important. We just return any type of document as long as it matches the requirement that we are going to be taking a look in a few. But the output is going to connect those dots for us pretty easily. So as you can see, we will be saving information into CosmosDB without writing any additional code. Moving to the Azure portal, we can take a look into the container side for CosmosDB. We are not going to do a deep dive. I will be doing an additional video throughout the weeks in order to cover CosmosDB in full depth. What I want you to see is that we have a database which name is going to be ImageDB. We also are going to have a container which you can compare to something pretty similar to a database table, but remember CosmosDB doesn't store structured data but actually unstructured data, so you don't have to wait for a particular columns on any particular structure that it needs to comply with the schema designs. But there are a couple of things that are pretty important in here. When you define a container, you need to specify the partition key. In this case, the partition key that we are going to be using is going to be image ID. We also provide the ID, which is going to be the unique set ID for the row that is getting inserted as each one of these documents. When the output of CosmosDB gets executed, a new document will be created in here with the information that has been extracted from the cognitive services. So let's go back and let's move ahead with the next step, where we are going to be processing the input for CosmosDB and sending the result back to SignalR. Now in here, with the CosmosDB trigger, we have something pretty similar as well. We are reacting to a CosmosDB trigger, and I want you to see that we are reacting to the ImageDB database into the container images. We are also using the same connection string that for the previous Azure function that we had. And in this case, we need to specify something pretty important, which is going to be the list container name. A list container is a container that gets created as part of the database as well, which is going to allow us to keep the state of the application when we are using the feedback to react to events that are triggered into CosmosDB. So as a quick example, each time that we put a document, the Azure function is going to be triggered async eventually. And the list container is actually going to save the states of the items that have been processed. We are going to be taking a look in the next video about CosmosDB and the list container. I just wanted to mention that because it's actually very important for the trigger. Now going back in here, this is one of the more simple Azure functions that we have into this document. We are just sending a new output, which is going to be the SignalR output. We are using a hub, which is going to be named images. And we are using the connection string named Azure SignalR connection string, which is located also in the local settings.json. So now with the output, as you remember, in this case we are just sending a SignalR message action, and we are passing as the arguments the input that we have. And the input is going to be the document that is being written into CosmosDB. In this case, the document is going to represent the information that has been extracted for the cognitive services. Then again, don't worry too much about SignalR. We are going to be covering that one when we go into future videos, when we are going to give proper details into that. The SignalR service in this case is a self-hosted service into the Azure side, so we are leveraging once more the tools that I have in there in order to work with it. It's actually very important to mention that we are working with a serverless version of the SignalR. We have the default mode, the serverless, and also the classic one. We will cover that in future videos. From here, when the user is logged into the web application, eventually he's going to get a notification on the web UI through another function. So let's take a look. The negotiate function is the one that is going to allow any clients to connect to SignalR. So using the same connection string, any application is going to be able to connect to this SignalR instance using this Azure function. This Azure function actually does something pretty straightforward. It's going to get an authentication token for us on the SignalR service in the Azure side. So it's going to return the URL for this SignalR service and also the access token for it. That way, the web application will be able to connect directly to the SignalR service and exchange messages with the UI. So now let's take a look into the final part where the UI connects to SignalR, and we also get the messages through the demo. On the web application, we have something pretty simple. We are going to allow our user to upload an image. Now when the user uploads this image, this is going to kick up the HTTP trigger that we saw at the beginning of the video. From there, the whole process is going to be executed. So the blob will be copied to the blob storage, and after that is going to kick up the blob trigger. The blob trigger is going to extract the tags, the metadata, and everything from the image, and that is going to be saved into CosmosDB. Then the CosmosDB trigger will be executed, which is going to send back the information through a SignalR. So eventually you will see that the user is going to receive all the results for the image processing in here into the screen in an async manner. So on the UI we have something that is pretty simple. This is just a JavaScript code. I just wanted to take a look especially to the SignalR. So we open a connection to the Azure function that we are going to be hosting locally, and this is going to call eventually the negotiate function that we saw earlier, this one. The negotiate is going to open the connection and is going to allow the web application to have a persistent connection with SignalR. Now, every time that an image processing event gets executed, we are going to be able to display the image to the user. Just as a quick reminder, when we have the image process, we specify which method we would like to execute. Remember that you can specify whatever target you want in here, give whatever name you would like to give, but between the function which dispatches the message and also the consumer, you need to make sure those two names matches. Otherwise, the message is not going to be never processed. You could have multiple events in here, not only image process, you can add as many as you want and react to those events when they get written into the SignalR service. Now let's take a look into the execution into the Azure side. Now the first thing that we need to do again is use the func host start in order to execute our functions. If we take a look into the execution, we will find a couple of things. We have 4 functions. We have the negotiate, we have the upload function, of course, and we have the blob trigger and the CosmosDB trigger. So let's go back into the web application and upload an image pretty quickly so we can see everything in action. Now let's upload an image. This image is going to be a New York image, so this is going to be the one that we are going to be extracting the metadata. So let's send this image to the Azure function. Now the first thing that we are going to get back is going to be the signed URL, so we can see the image in here from the Azure container. So you will see a few seconds later, as soon as all the Azure functions get executed, we will get the image details. So we are going to get the image ID, the description, and the tags of the objects that have been extracted by the cognitive service. Okay, so let's take a look. So the description, it says this is a group of people crossing the street, and a couple of things that the cognitive service identifies, like clothing, footwear, cars, people, and something different. Also, between objects, we have tire, footwear, a different person, and a taxi into the image. So if we take a look into the image as a human being, we can see this is actually pretty accurate, and a lot of the images has been detected. Let's go back into the ED very quickly just to explore a couple of things. So we go in here, we will take a look how all the execution has been done since the beginning of the execution. Don't pay attention to the red errors that you see in here. This is because the Azure authentication is using the default credentials, so he tries to authenticate until he finds that is going to be the Azure CLI. So in here, we execute the API, is going to put everything into the Azure side. We have everything ready to go. And all the Azure functions are going to be executed one by one. So you can see we have put up the document to the blob storage, and after that we return the delegation key, which is part of the initial process as well for the Azure Blob Storage processing, which is going to be sent to the CosmosDB document, and all the processing happens through in here. Now after that we have interaction with the cognitive services in here as well. We extract all the metadata, and as part of the output we send all the information to CosmosDB, as you can see in here. Now once more we have the final output, which is going to be the CosmosDB trigger function, and that is going to kick up the SignalR as you saw throughout the demo. So the main important thing that I would like to highlight in here is that using Azure Functions you can build easily highly scalable applications, because you can create components that are fully isolated with particular tasks, and this is the core or event-driven application and also microservices. So in the next videos we are going to be doing a quick dive into important services from Azure like CosmosDB and SignalR, and after that we will be kicking up a new series of videos where we are going to be working with microservices and event-driven applications, so you can learn how to implement those in the Azure portal as a developer or even as a software architect. Thank you for following me, and see you in the next video.